and welcome to this, our fifth in our series of webinars as part of our 50th anniversary celebration. Next slide. For those of you that aren't familiar with us, EA was founded in 1973 by Dr. Lauren Jensen as ecological analysts. The company grew from a small office in Baltimore to a geographic footprint spanning the US and its territories. Along the way, we became a 100% employee-owned public benefit corporation with a core purpose of improving the quality of the environment in which we live, one project at a time. Next slide. Now I'd like to introduce today's speakers who will be providing a discussion of the digital transformation of the environmental industry. Jason Stamos is EA's Director of Technology Solutions, as well as Lead Quality Technical Chief for Information Technology and Data Management. Beth Strachwin is a Senior Civil and Environmental Engineer, a Project Manager, and the firm's Asset Management Program Lead. And Luke Flores is an engineer specializing in modeling. Now I'm going to turn it over to Jason to get us started.
Awesome. Thank you, Amy. And thank you, everybody, for logging in today. We appreciate you sort of carving out some time to join us and hear a little bit about how technology is changing in the environmental industry. Our agenda for today is here on the slide. To start things off, we thought it would be a good idea to maybe give a brief introduction and talk about the current data technology landscape as a whole from a broad brush perspective, to provide a little context for the larger ongoing discussion, which we will use the data lifecycle there, the graphic there on the right-hand side, to kind of facilitate the conversation. For each step of the lifecycle, we will walk through technologies that are commonly used today and how they're actually used, and then discuss some key considerations to keep in mind when you're selecting amongst the various technologies that are available for you to support that stage of the lifecycle. And then we'll present a key use case for each of those steps, kind of illustrating the use of some of the technologies we talked about. After that, we'll then look to a couple future technologies. While there's a lot that we could talk about there, we're going to focus our conversation on two emerging technologies and kind of where they are and how you can actually start to use those today. And then we will wrap things up with a few parting thoughts and then move on to Q&A. So as I mentioned, we're going to sort of start the conversation off with just a broad brush overview of the current technology landscape. And our goal today is really to provide that broad overview of all the technologies that could be available. Rather than picking one or two technologies and diving deep, we felt it might be most beneficial to give folks kind of an idea of all the things that are out there that are available for you to use to support your projects or efforts moving forward. And then when I think about sort of that broad I guess, landscape of technology, it really falls into kind of three key themes, if you will. More, simpler, and greater accessibility. And what I mean by that is, for more, there's just larger volumes of data that we can collect now, and we need to find ways to store and manage that information. With the ease and ability of data collection tools, which we'll talk about here in a little bit, it generates an ample amount of data for us to then manage, store, and then use for our analysis. And that's really been enabled through things like the cloud and SaaS infrastructure, where we can easily and readily spin up additional capabilities to store more information as it comes available. Now, that has also driven the need for more interconnectedness across our systems and a greater degree of integration across the tools that we use, and we'll speak about those in a little bit. Second sort of key theme here is simpler. And the first bullet here might be a little counterintuitive when I say more complex sensors, but what I mean by that is sensors themselves have gotten more complex, where you can actually start to capture multiple variables or multiple, I guess, methods or samples with a single sensor, and they've gotten smaller as well. So that's actually made things simpler for us as environmental professionals for capturing information, where we don't have to deploy multiple sensors in a given spot. We can actually use one sensor to capture a lot of the information that we need to. And then with the advent of low-code and business intelligence platforms, it's now much easier for folks who are not necessarily programmers to create tools to capture information and then report that information to themselves and their peers. And that kind of leads to the final thought here in terms of greater accessibility. Since we have this wide array of additional information and the tools available for folks to create platforms to share that information is now much more available to folks across multiple different devices, such as your computer or your mobile devices. So that's kind of a broad overview, just to kind of set the stage a little bit for what we'll be talking about. And now we'll kind of move into the first stage of the data lifecycle, which hopefully is pretty obvious. It's data collection, right? That's where everything starts. We gotta collect the information first. And we've got a few technologies listed here. This is by no means sort of meant to be the list of everything, but a few key technologies that we wanted to talk about. The first would be the use of mobile devices with a no or low code form builders. So mobile devices themselves aren't necessarily a new technology available for folks to use to capture information, but the advent and the prevalence now of no and low code platforms to allow folks to create their own forms is really actually sort of driving the further use of these tools. We have the concept of a citizen developer being able to create forms for surveys, inspections, sampling events, chain of custodies, and then promote those and provide them to their field staff while they're in the field. The second sort of key technology here would be the use of remote sensors paired with telemetry. Again, the use of sensors isn't necessarily a new topic, but as I mentioned before, the fact that sensors are becoming more complex and more capable, within a single sensor, and the ability to sort of easily pair those with a telemetry system, such as cellular or Wi-Fi or sometimes satellite, has really sort of seen the rise in the use of these in cases where maybe we historically or traditionally hadn't used them before. So we can do things like real-time monitoring for air quality at ongoing construction sites, or even turbidity monitoring with sort of in-water activity, and even monitor things like landfill temperature or even landfill gas emissions. And then finally, we've got drones, which drones themselves aren't necessarily a data collection tool, but they are actually a platform for your data collection tools. So again, drones themselves have been around for a little bit of time, and most folks are probably familiar with the use of drones for capturing things like imagery, whether that be aerial photos or videos. But as the technology has become more prevalent and the sensors themselves have become smaller and lighter and more complex, we can now capture a whole array of additional information using the drone as actually a platform for our data collection tools. So we have specialized sensors like infrared, thermal, and even air sampling that can be drone based for capturing information in remote areas. And really, we've seen sort of the rise in use of drone technology for things like site reconnaissance, document sort of construction or remediation progress at given sites, and also the creation of 3D models based off of those photos and videos that have been captured. So with that, there's actually several, as you can kind of see here by the bullets in the slide, key considerations to keep in mind when you're selecting which data collection tool you might want to use. I'm not going to go into all of these for the sake of time, but I will hit a few of these, off the top. The first thing to note when we're talking about sensors are great for capturing readings, but they don't necessarily tell you what the source of that reading is. A good example would be, external factors impacting the readings from things like wildfire or other activities that might be occurring in the area, like mowing or even athletic activities at a high school, which I'll talk about actually in a second during our use case. For the drones perspective, an FAA license is required for commercial use of drones. And at the end of the day, like I said, the drone is actually the platform for capturing information. So the actual type of sensor you need to capture the data that you want is going to drive the type and size of drone that you ultimately deploy. When we think about data, one thing I'll caution folks on is, I mentioned greater amounts of data, higher volume of data that can be captured in real time. It's a little bit of a double-edged sword. Great, high volume of data for use for continuous monitoring is great, when you want to be alerted for a change in conditions at the site. However, that same volume of data can pose challenges to you when you're looking to summarize or report or aggregate that information for longer-term reporting. And then finally, when we talk about mobile devices and capabilities, it's really key to think about, while the prevalence of connectivity is pretty wide and available now, there are still those times where you might be in the field and you'll lose connectivity. So when you're looking for a mobile platform, you want to make sure that it has the ability to work offline, so that way you don't lose any information that you might have captured while you're in the field. The case we'll talk about here for data collection is some ongoing work at a former mining site in Jackson, California. It's the Argonaut former hard rock gold mine site that was in operation for about a century, starting in the 1850s. The current activity at the site is the removal of about 100,000 cubic yards of arsenic-contaminated soils and tailings from the tailings impacted areas around the former site. Currently, construction of an on-site repository for all the removed material is underway. And there's also construction of stormwater improvements to actually improve the surface water diversion within the site itself. So the challenges posed by this is the site is conveniently adjacent to several public areas. There is a high school to the east and a middle school, I think, to the west, and then residential areas to the north, with the former mining site right in the middle of all of those. So this, poses a significant risk for, unintentional exposure from dust, if you will, during the activities to those constituents. So the need for real-time monitoring of particulate matter 10 being used as a surrogate for arsenic was key to ensure that the activity within the site was not going to negatively impact the surrounding residents and community. To achieve that real-time monitoring, 8 discrete monitors are positioned around the site. You can kind of see those locations by the gray and red dots there on the map. At each of those sites, we deployed a TSI dust track DRX aerosol monitor, which is a mouthful, and it has the ability to simultaneously capture PM1, 2.5, 5, 10, and total PM every second. So this system actually records those readings every second, and then through the use of cellular-based telemetry, it uploads that information at the exact same time to a cloud-based data storage system. And within that storage system, we actually are able to leverage that to provide alerts. In this case, we're using 5 and 15-minute rolling averages of PM10 concentration to staff on site. Depending on where the activity, during the day is occurring, the RSL value is actually different in terms of what the threshold needs to be alerted for. So the portal tool that we're using for the alerts provides easy ability to modify that RSL or threshold value. It also provides an easy ability to select multiple methods for sending alerts, whether it's text, email, or even phone calls to multiple recipients. All of which, at the end of the day, allows us to sort of take action at the site should particular parameters be eclipsed. And in this case, we've got a nice photo of some watering activity to keep the dust levels down while construction activity continues to occur at the site. And so with that, I'm now going to turn it over to Beth Strachan, and she's going to talk about our data management.
Thanks, Jason. Now that we discussed the data being collected, the next question is, how do we manage that data? There are several key considerations when managing data. And these considerations are about the tools or actually the systems of managing the data. The first one is you want to have one database. You want to have one system of truth so that you only have to refer to one data set. With that, we want to promote security, standardization, and normalization of the data so that you have that consistent, reliable information. However that data is being collected, we want to make sure that within the system, we can have the data collection, the QAC policies, and reporting out. And then from that, the data is living onwards. So another key consideration is the data governance. How do we maintain that data long-term? What standards are we requiring? In this system, or this part of the presentation, we're going to be talking about 2 specific platforms specific for environmental work. One is the analytical and geological data that is housed or hosted by another platform called EarthSoft Aquis platform. Now, this data management system specializes in collecting analytical results for both the samples being taken or actually just for the samples being taken. But the neat thing about the system, it actually allows you to collect other pieces like your trip blanks and your duplicates so that you are collecting the information and managing it for meeting those environmental parameters. With that, we also have the QA/QC and aggregation of that data that's custom with, or actually that comes with that platform. And EA right now, we have 800 active sites that we are working on using the analytical that we are storing our analytical data in, which is almost, from 2,000 sample records to 5 million records of analytical data. And with the Esri EarthSoft, not the Esri, excuse me, the EarthSoft Aquis platform, you also have the Esri ArcGIS Align spatial platform, so you can spatially see that data. And we'll actually show an example of those 2 systems coupled together in a little bit. The other tool that we usually use a lot is asset management systems. And the one I'm going to be speaking to is actually Cartograph. There are many asset management systems out there. They actually provide a geospatial inventory of your assets, your infrastructure, allows you to track the work and effort performed on maintaining those assets. And there are not only asset management, but then you can also get into your environmental compliance and your safety management systems that are all specialized in maintaining the data in a specific format for those specific uses. So next slide, Jason. So in general, with data management, some things to emphasize is there are tools out there. Embrace the specialization. These tools are designed so that you don't have to redo that design yourself. Location of the tools, we talked about SaaS briefly, having the information available in the cloud so that it is accessible both in the field and it is securely managed. There are infrastructure requirements for some of these systems, making sure that you're building the platform on the same tools. The other thing with the data management system is you have to have dedicated staff to maintain this information. It's not a set it and forget it type philosophy, making sure that people are responsible for maintaining and managing the data and the ability to integrate with other systems. And we're going to talk about how this data is actually shared for that reporting piece. Next slide, Jason. So the use case that we're going to talk about for this one is actually Frederick County, Maryland. This client went ahead and implemented an enterprise-wide asset management system. They selected the product called Cartograph, and the EA was the project management support for the implementation of this. The goal of this project was the county wanted to reduce the siloing and standardize the work that's being tracked for all of the county's assets. They wanted transparency so that the assets had the priority of being maintained for the next elected leadership. And when I say all of the county's assets, I'm talking water, sewer, parks and rec, solid waste, public works, and emergency management. All of those different entities had different assets, and the county had opted to use this one product as a data management system to maintain all of that infrastructure information so that they could have that transparency. Frederick County, Maryland is actually the largest county in the state of Maryland and has the county itself has employs about 2,500 people. With this project, what EA was able to do was actually help 350 users adopt the system and actually use it for their daily work. There's 270,000 assets. So every picnic bench, every leachate collection system, every storm drain is all managed in the system so the county can track that work and that information. And that is actually the data management system. With that, I'll turn it back over. Oh, thank you. No, my apologies. So some of the actually great results from this project was there was a stakeholder coordination, which is what EA is responsible for making sure we did. And through that, there was actually a rethinking of existing processes. So everybody had actually standardized their operations for similar assets. And all of the data is now geo-referenced. This project actually happened in about 20 months. We started in December 2020, which was right in the middle of COVID, and we were actually able to do the majority of this work remotely with these clients. And another part of this was brought in for that asset management goal was the constituent services, making sure that as a constituents report issue, it actually tied into the assets that they were reporting on so they could see the full picture of that asset. The county implemented the full suite of the Cartograph functionality. And through that, they now have a knowledge transfer as older people retire, new people come in, they can refer back to the data on this system. And there's guides for moving forward. They know that all work is to be tracked in the system and everybody is recording their work. And now they're getting new operational insights. The information is accessible remotely and they are using actually tablets and phones in the field. If you want to learn more about this project, definitely scan the QR code on the right. And with this, I apologize, Jason, but I will turn it back over to you.
Thank you very much, Beth. Okay, so far we've heard about how we collect the information and technology we use for managing the information. Now that we have it, let's talk about how we could, do some analysis on it, which honestly is really the whole point, right? When we think about data analysis, I kind of put this into sort of 3 tiers, if you will, of complexity for analysis. The first being kind of basic summarization and charting of information. There's not really a whole lot new here from a technology perspective, but the one thing we wanted to sort of draw folks' attention to is, I'm sure many folks on the call today are probably familiar with tools like Microsoft Excel or Microsoft Access, but you might not be familiar with, some specialized charting software like Origin Pro, which is really, geared towards solely producing charts and visuals of charted information for publications or poster presentations. It's a really sort of sophisticated software tool that provides, a vast array of charting capabilities and produces pretty aesthetically pleasing charts at that. When we kind of think about the next tier here, we sort of think about visualizations. There's a number of different things that fall into this category. We've got several listed here, like boring logs, conceptual site models. On the 2D side, we've got on the 3D side, we have 3D block diagrams or ISO surfaces. And again, kind of the distinction here in terms of new technologies is more about better capabilities within existing tools. So we have tried and true tools that have been around for quite some time and still do a fantastic job. Things like Rockware's RockWorks or CTEK's EVS. That are used to produce all these types of visualizations that I talked about. The real sort of advancement, if you will, across these is more towards ease of use from a user interface perspective, as well as the ultimate end product being more aesthetically pleasing and sort of present better presentation to the end users. And you have tools like Leapfrog that kind of specialize in that area, all the way to the potential automation of the creation of these tools. When you think about a tool like Enviro Insight that ties back into an Equus data management system, and as long as you are capturing your boring information, your well construction information, those visualizations can be automatically created as soon as the data is entered into the system. The final tier here, the most complex, if you will, when we sort of think about statistical analysis and modeling, sort of driving things like decision support or even predictive modeling. At the end of the day, the technologies here really haven't changed. We've got traditional tools like HEC-RAS, ModFlow, and even SAS. I'd say the major change from beyond what folks might be familiar with would be sort of the user interfaces for these tools, making them slightly more intuitive and accessible or approachable by folks to sort of use those really powerful modeling engines, behind them. And then when we think about key considerations for selecting the tools, we've got a couple listed here. The first would be the idea that there's actually going to be multiple factors that will probably drive your decision making in terms of which tool you pick. Kind of alluded to this in the previous slide. The level of analysis required, whether it's just basic charting or I need to do predictive modeling, is going to drive kind of the tier of tool that you're looking at. And then, within that, the ultimate sort of deliverable or output or visualization and the quality that you're looking to achieve will probably will have a factor there as well in terms of which tool you want to ultimately employ to support your effort. For most of these, you're going to need staff that are trained in the use of the tool and subject matter experts, with actually the understanding of the information as well to be able to effectively use them. And then, integration with your data management system is actually a really key factor to keep in mind. It's going to help you sort of minimize any potential quality issues with the, manual handling information from a system, exporting from your system and into your visualization system. Whereas if you can have those tools, automatically integrated in, you can avoid that whole manual process and then have the systems talk directly to each other. And so with that, I'm going to turn it over to Luke Flores, and he's going to talk about our the use case we have for data analysis.
Great. Thanks, Jason. So this use case, the client was EPA. The site consists of a fairly large PCE and other chlorinated solvents plume, about 5 miles long, in a fairly urban environment. And the sort of overarching problem or goal is to optimize an existing monitoring well network. And so this case, I think, is a really good example of sort of this natural data cycle that both Beth and Jason have been speaking about, in that the client has done already extensive data collection over the site's history, in some cases over 40 years of data collection. And so this has resulted in, as you can imagine, a really large database, and EPA and the client had gotten to the point where they were sort of asking, what do we do with this now? How can we use this database to help us? And so this is really what resulted in the problem. And so, as I said, the site has close to about 300 monitoring wells that are infrequently sampled or have been infrequently sampled. And the site lacks a defined, organized, focused sampling program. Adding to this problem is that among these 300 wells, about 100 are small diameter wells of less than an inch. And this has complicated sampling logistics over the site's history. And so the objective is, how can we optimize this well network? And by that, I mean, how many wells should we be sampling, which wells to sample, where should we be sampling, when to sample, how frequently? And again, sort of flowing from that, as well as identifying these small diameter wells that should be replaced for future sampling or abandoned and destroyed. Next slide, please, Jason. So hopefully, without generalizing or oversimplifying, I think I would argue, at least for this site, optimization can really just be defined as reducing redundancy and reducing uncertainty within the well network. We don't want to under-characterize, leading to uncertainty, and we don't want to over-characterize, resulting in redundancy. And so to sort of address these two metrics, we use two different softwares. The first is MAROS, which stands for Monitoring and Remediation Optimization System. MAROS is a free open source software maintained by GIS Environmental, originally developed for the Air Force Civil Engineer Center. MAROS uses a Microsoft Access interface and reads in data that is typical of a standard well database. So well IDs, spatial location coordinates, vertical information such as well screens, and time series of concentration data, analyte concentration data. And MAROS does perform quite a few analyses, things like trend analysis, Mann-Kendall, center of mass of the plume. But how we used it here is that MAROS, one of the things it does is provides a quantitative rank of wells based on their importance to the well network. And by that, I mean it ranks wells based on how important they are in achieving delineation. So what this allows us to do is identify redundancy, which wells, if we were to remove from the system, do not result in a significant loss of information. In tandem with this, we used EVS. And EVS is typically used more commonly as a data visualization software, interpolating 3D data, making things like plumes. But in addition to the interpolations that EVS outputs, it also provides corresponding 3D fields of confidence of those interpolations. And so this allows us to identify uncertainty. And so using these two softwares, we're able to sort of balance out these two ideas, redundancy and uncertainty, and ultimately quantify the statistically optimal number of wells to be sampling for the program. And this is really what results in an optimized well network. And so ultimately, the end result here is that we were able to show that we can achieve the same level of plume delineation and confidence by sampling just 70 wells, correctly selected 70 wells, as opposed to 120, which is roughly what the client had been sampling. And we estimated that this results in about a $200,000 reduction in sampling costs over 5 years. And along with this, we address the secondary objective of these small diameter wells. We can decipher which ones are necessary for the ongoing characterization of the well network. And that's it. Thank you, Jason.
Awesome. Thank you, Luke. Okay, so now we're going to move on to sort of the last part of the life cycle we'll talk about today, which is really sharing and reporting. We've done some fantastic analysis. We now want to provide access to that, whether in draft or primary or final form, to folks. And so there's really, two sort of categories of technologies that are employed today to provide that. The first one is sort of, web or even mobile-based dashboards and portals. Over the course of the last several years, this has become what I would argue is the standard method, honestly, for sharing information for the entire project team, whether that's within your organization or other organizations you might be partnered with, or even key stakeholders like your client or even the public or regulators. These dashboards and portals provide a variety of capabilities, and they're usually specialized based off of what I would say is the primary type of information you want to present. So if we're talking about things like analytical information, where we're going to have more maybe tabular or graphical based data, that you'll have a dashboard maybe from your ecosystem or something like that. Or if I have more geospatial or location oriented information, I might use something from Esri's suite of tools for having a web-based dashboard along those lines. And sort of to that point, there's actually lots of platform options available to you. Ideally, the data management system that you've employed will have these tools already built in, and you can leverage those from an efficiency and sort of quality perspective. But in the cases where maybe they don't, or what you're trying to accomplish can't quite be done, there are several standalone tools available. I've got a couple listed here in terms of Microsoft Power BI or Tableau, which provide very robust reporting and dashboarding capabilities, and are relatively easy for I'd say the average, or entry level, maybe data scientist to use, or even sort of citizen developer to use or employ to share their information. If we want to sort of think beyond just sharing of data and more, actual collaboration, across your project team to sort of comment or provide information, in sort of draft form, there's a whole series of platforms out there to facilitate as well. I'm sure all of us saw the rise of several of these, over the last several years during the pandemic. And now, these tools are very prevalent as well, and, frankly, serve as a centralized platform for all team members to access data. So you have, use cases ranging from basic, I'd say, document editing or contributions along those lines, all the way to, more sophisticated efforts where we're, collaborating on design files or within our digital twins for, entities that we're, constructing. And so when we're thinking about our data sharing or collaboration tools, there's a handful of key considerations to keep in mind. The first thing I'd like to just throw out there is the frequency of reporting and/or data updates. So really, that's going to drive whether a dashboard is the best approach for you. So if your information does not change very frequently, maybe you're sampling or have data updates every year or every 2 years, an online dashboard might be a little overkill, perhaps in that scenario. Versus if you have something that shows much more frequently, then having readily accessible information might be a better choice. You also want to keep in mind your intended audience, and what I mean by that is the end user. Your technical staff are going to want a much more complex dashboard where they can do more robust querying of the information, whereas decision makers who aren't necessarily working with the data every day would probably appreciate a more streamlined set of tools where they can come in, do some very basic querying to sort of get to the end answer that they're looking for. All of this to say is, at the end of the day, the data itself will probably drive the type of dashboard that you implement. And I kind of talked about that in the previous slide. And I also just want to leave folks with the thought that, automatic access to newly acquired data is not necessarily a good thing in all instances. So back to the technical staff, it might be great for them to have access to what we would consider preliminary data very quickly. But you might not necessarily want to make access to that preliminary data available to all, users of the information. So this might actually dictate a scenario where you have two different dashboards in place, or at least some mechanism to stage gate access to that information within the dashboard, so that you're only providing final or QA/QC data to the ultimate end users, like perhaps the public or key stakeholders. And so the use case we'll talk about here is another former mine in California. This is the Copper Bluff mine. It was a former copper and zinc mine. It was in use for only about 5 years, sort of just north of, or I guess just above the Trinity River. The challenge there's currently acid mine drainage and metals discharge from the portal entrance. You can kind of see that orange staining down the cliffside there in the DEM behind. And so one of the aspects of the project is to identify what the possible source of the rain or stormwater intrusion is that's leading to that discharge. What complicates that is that the vast majority of the adit system is abandoned and actually unsafe for human entry. So to help overcome that, the use of drones within the mine site itself, along with traditional sort of GIS tools, were employed, and that data was all combined and made available through a dashboard, which we're showing here. So we combined the combination of a digital elevation model, which is the hillside, 3D model from historical records, which is the colorful, I guess, adits and lines there in the backdrop. A 3D model that was generated from the drone flight and the walkthrough for the areas that were accessible, which is sort of the orange grouping of lines there. All combined into this viewer, which allowed the project team to effectively virtually investigate the adits. So the sort of value here is by using the live captured information from the drone, we were able to actually validate how accurate the historical records were, which were from 1959 for the rest of the adit system. And it actually overlaid really, really well, which gave the team a very high level of confidence that the maps for the old adit system were probably fairly accurate. It also allowed us to sort of identify areas within the DEM where there could be intrusion sort of coming in. When you sort of look at the top of the DEM, there's sort of the elevation model there, you can see sort of depressions and kind of identify how they line up with some of the chutes within the adit system here. Beyond this sort of visualization piece, there's other elements within this dashboard. In this case, we've got some hydrographs depicting rainfall at the site, and it's also combined with, if you sort of look at the top left there, the tabs, the data grid, which provides access to some of the analytical data that's available within the system as well. So this is a really great example of sort of a multimedia, if you will, dashboard that combines a lot of different types of information and made available to the entire project team. Another quick example I wanted to show here is from the use of some of those low-code tools. In this case, it's the Microsoft Power Platform. So we're talking about the combination of Microsoft Power Apps, Microsoft Power BI, and then ultimately Microsoft Power Automate for automating some of the activities in the background. In this case, it was used for an organization that had about 230 facilities. So they wanted to do some environmental risk scoring and then ultimately ranking of their mitigation program against those scoring at all those facilities, and then socialize and make that information available to the rest of the organization. So the combination of these tools allowed them to quickly stand up a tool, which is on the top there, to capture the details for the risk scoring. And then the charts and graphs there are examples from Power BI that were used to sort of socialize or report out or share the results of that risk evaluation to the rest of the organization to help them communicate where their risks are and sort of areas that they need to focus attention on. All right, so we're going to shift gears a little bit now and start to talk about technologies that are going to start impacting the environmental industry in the coming future, if you will. And so in this area, there's actually a variety of technologies that we could talk about from an emerging perspective. I've got a few listed there, like the industrial Internet of Things, which is just basically everything connected to everything else. Concept of augmented reality, where I have a physical device that I'm using to view digital information while I'm also in the real world. Or even, as crazy as it might sound, the concept of the metaverse, where I have a completely virtual environment and I can use that to display and traverse my digital twins or things along those lines. Unfortunately, because of the sake of time, we're not going to be able to dive into those technologies specifically. Instead, we've decided to focus on two other emerging technologies that we feel you can actually start leveraging today and start to see benefits of the use of those within your organization now. And that's reality capture and everybody's, I'm sure, hot topic that we're hearing a lot about, artificial intelligence and machine learning. So first, we'll talk about reality capture. The concept of reality capture actually, I should say maybe the components of it have actually been around for a while. It's here recently where changes across those components and other variables have come into play to really make this a sort of a collection of tools that can be easily packaged and put together for tremendous use. And what I mean by that is, the cost for capturing, I guess, the data for creating these 3D models, whether it be based off of photos, videos, or LiDAR, has come down significantly over the last, let's call it, 20 years. And you kind of see the graph there, all the way to the point where I would bet probably half, if not more of you, have a LiDAR camera in your pocket right now. So anybody who's using an iPhone or an iPad 12 or greater, you have a LiDAR camera attached to that device. And that's really sort of enabled the easy capture of high quality, high density information that can then be used to create 3D models of various physical objects or even areas within a site. Along with that, the fact that you could probably use tools you already have to process that information, like Esri's ArcGIS Pro, or even commercially available tools through like the Apple Store, really kind of drive down the cost and time and effort it takes to create these 3D meshes and visualizations from that data. And then the ability to share that information is the same sort of scenario where you probably already have tools in place that you could implement, things like Esri's ArcGIS Web Viewers or Autodesk Recap, to share this information to key stakeholders. And the typical use cases that we're seeing, at least that we've sort of experienced ourselves within at our organization, would be to sort of track the conditions of sites over time, whether that's construction activity or natural activity like erosion, and really use the technologies and the tools, the viewers, to provide pretty detailed representation of whether it's a structures or physical environment for all stages of the project lifecycle, whether it's from planning to archiving of information for historical purposes, and before maybe activities occur at a particular site, and then ongoing management of sites as well. And so, got a couple examples here of what's termed reality capture. This first one, I will admit, is actually on a fairly basic example. This is from a shoreline in Point Hope, Alaska. This 3D model that we're looking at here, and this is a 3D model, was captured, or I should say created, using photogrammetry techniques from photos captured from drone flights at the location. There's actually a series of 3D models here, which we didn't have the time to really sort of go into, that sort of depict the erosion at the site. But the reason why I wanted to sort of show this is something that's available today, and can be used for reality capture to actually walk the site. I also want to use this to kind of compare and contrast the other example I have, which is from the Argonaut mine site that we talked about before. And these are former cyanide tanks at the processing facility at the mine site. This example that we're looking at here was actually captured on an iPad from a staff member in the field. It took them roughly 30 minutes to capture this using their iPad, and then upload it and make it available for the project team. The driver for capturing this was for historical documentation purposes, in case ongoing efforts at the construction site had some inadvertently sort of impacted this area. We wanted to memorialize as much as we could of the current site for historical preservation perspectives. You'll also notice within this that there might be some areas that are fuzzy, and I kind of did this on purpose. This is actually the raw model that was taken straight from the iPad, not the sort of processed or cleaned up version, just to really illustrate the high level of quality that you can very easily create with your devices in a short period of time. And then for those who have more needs, that maybe where we need to clean up some of the fuzziness, it's very easily corrected, I guess, back in the office with existing tools that you probably already have that I mentioned before, to create sort of a final production quality version of this model. So this is a great example of how you can use easily, readily available tools now to create these types of reality capture or 3D models for use within your program. The last technology we'll talk about, which I'm sure everybody has been hearing a lot about recently, is artificial intelligence and machine learning. And really what I want to focus on is the last bullet there on the bottom, generative AI. But to kind of put that in context, I wanted to kind of give a little bit of a backdrop of the whole sort of artificial intelligence technology concept, where at the top of the model here, AI is really the name we give the science for a machine's ability to perform cognitive functions that are, we associate with human minds. And within that AI, a subsection of that is called machine learning, which is a form of artificial intelligence that's kind of based off of algorithms that are trained with data that we provide to it to ultimately detect patterns and make recommendations based on that information. And then a subset of that is the concept called deep learning, which uses neural networks similar to the human brain in concept to ingest data and process it through multiple iterations to actually make those large language models that we probably all have heard of, which then gets us to generative AI, which is really the combination of a large language model that was developed through deep learning processes, combined with most likely a natural language processing, so the ability for chatting, typing in a question in regular language, to then ultimately produce new content based off the information and algorithms within the large language model. The easiest example of this, which I'm sure everyone has heard of, is ChatGPT, and it's a great example of a generative AI large language model using natural language processing as the user interface for folks to pose questions to it. So with that kind of backdrop, I wanted to talk honestly real briefly about how you can be using generative AI today. And I've got a couple use cases here that are actually examples of things that we are doing ourselves now within our organization in terms of pilots to take advantage of the capabilities that are out there when we think about generative AI. So using natural language processing, we have some pilot examples of doing summarization. So creating summaries of projects or even staff resumes based off of the volumes of data that we have in terms of documentation within our network to produce those summarizations very quickly. The concept of entity extraction for reviewing contracts and identifying terms that traditionally there might be issues with, and proposing changes to those terms based off of what our traditional or desired language might be. The ability to sort of do rewriting or technical editing of reports or even emails as well. And then the concept of a training portal, where if you think about combining your organization's I'm sure volumes or vast amount of standard operating procedures, policies, guidance that all exist maybe in like an intranet fashion, but putting all that information within a single interface where a user can ask a very simple question and then get the detailed response back from the combination of those tools is actually a really powerful concept, and something that's we are working on ourselves. Beyond those pilots, you've also got the idea of computer vision. So this is sort of a combination of either generating images. You may have heard of other than ChatGPT, maybe DALL-E, for those who are familiar, is a public-facing model for creating images using natural language processing. And also the concept of image classification or object detection within photos or videos that you captured to easily classify assets, sort of circling back to Cartograph and the asset management system that Beth was talking about to help populate those data management systems. So these are really basic examples, easy examples that you can employ today within your organization to start taking advantage of generative AI and start to figure out how you can use that and leverage it for your purposes now and honestly moving forward. But in that context, I did want to sort of talk about a few key risks and considerations when you're thinking about AI. And for those who are familiar with like ChatGPT or keeping up with this in the news, these are probably not going to be new to you. But we've got the challenges associated with accuracy of the generated data, and sort of what I mean by that is there's natural bias within the ChatGPT framework itself, and this is based on the fact that it was trained on publicly available internet-based data, which in itself has an inherent bias within it based off of the idea or the fact that most content can be published up there by anybody. There's also the challenge of a hallucination, which is sort of a fancy way, if you will, of basically it giving you a wrong answer. Because the idea is that in some cases, the model is trained to always give you an answer, whether it can find a good one or not, it's going to give you something back as a result. And so that's really, a cautionary sort of fact there that, don't take sort of the responses you receive at face value. Treat them as more of a starting point for ultimately what you would then need to, modify yourself to get to a final product. There are also legal and regulatory concerns associated to the content created through these. Copyright issues and work product ownership questions are, I'm saying, very gray area. There's not really a whole lot of legal precedents yet along those lines, but you're starting to see some movement, or actually some cases being brought up along these lines. So it's something to sort of keep in the back of your head when you're thinking about how you use these. There's also privacy concerns, especially when you're talking about the use of public models. So the thing to keep in mind is whatever you would sort of input into a public model like ChatGPT automatically becomes publicly available as well. So you might not necessarily want to put in personally identifiable information or even project data from within your organization into this public model. Luckily, there is a relatively easy way to kind of mitigate most of those issues, and this is by implementing your own, what I'm calling a private large language model. There are a number of large vendors out there, Microsoft, Amazon, Oracle, and others that now provide the ability for organizations to create their own private sort of footprint or tenant and use these large language models like GPT 3.5 in a secure environment and with their company's their company's data. So back to those sort of pilots I put up there at the top of the slide. The value there is because we're able to bring our own information and use these large language models to source, I guess, that data and create those summaries. And that's really only achievable if we're in a secure, private environment where it's not publicly available. So I guess the take-home message here is there's a lot of capability available now. artificial intelligence and machine learning is a technology that is a game changer, not just for the environmental industry, but for lots of industries. And we're going to only see this, concept grow as time goes on. So I would, strongly encourage folks to start looking into this and starting to figure out how they might want to leverage this within their organization or what makes sense for them. And so with that, we'll sort of wrap up our talk today with a couple key takeaways that we wanted to leave behind. The first thought here is that there's a combination of technologies necessary to effectively manage your data throughout the data lifecycle. When we think about, collection, management, analysis, and reporting, there's different technologies used with every step and even within each step to facilitate those processes. And so because of that, integration of these technologies is really critical. We want to make sure that the tools that you pick can really interact and integrate easily with the other tools that you pick within the data management lifecycle there. And then just the idea that constant evolution of technology is a double-edged sword. It is fantastic in terms of providing advancements and additional capabilities that ultimately allow us to do things more efficiently and drive down costs and provide better end products to our clients and our end users. But when we're talking about new technologies, obsolescence of a given technology can actually happen really quickly. So you want to be careful about how and where you choose to invest your time and money in terms of which technology, to make sure that you're pretty diligent, I guess, if you will, in picking those technologies. So that way you don't necessarily invest in something that is, becomes obsolete within 6 to 9 months. And so with that, I'm going to turn it back over to Amy.
Thank you, Jason, Beth, and Luke. So let's turn to Q&A. I don't see any notes in the chat yet, but I have a question to start us off with, which is focused on AI. With the adoption of AI and machine learning, and it's really gaining momentum, what are your expectations for regulators to address reporting requirements for using AI when we're doing environmental planning or data analysis or engineering drawings?
Yeah, that's a great question. I guess the answer might not be that satisfying, I guess, at the moment. What we're sort of seeing right now is kind of a different tiers. I'll sort of start within organizations. We're starting to see organizations actually start to come up with their own guidance themselves in terms of where they are comfortable based off of their culture or their own guidance on the use of these technologies and sort of how they sort of fit into their workflows. We're also starting to see when folks, maybe in the general public or outside, use a tool like a ChatGPT, for example, to create content. They are actually citing ChatGPT as their source to kind of, be fully transparent about how that material was generated and sort of what was used to create it. And then on your question specifically there, Amy, about regulators, I would say in the spring of this year, there was a lot of conversation, a lot of discussion that Congress was going to be taking up action and would be, targeting to provide, I'd say, some preliminary guidance on the governance over AI by sometime this fall. Since then, haven't heard a whole lot about the process of that, and I don't. So I'm not really holding my breath. We'll see it this fall, kind of given everything that's going on within Congress right now and some other challenges they have to work with. But I would expect that in the not too distant future, there will be some, albeit initial, guidance on, to provide a framework, if you will, for how AI can be or could, be effectively or employed, I guess, to produce work output.
All right, any other questions? Okay, well, I don't see anything in the chat, so I think we can wrap this session up. Do you want to switch to the next slide? This is Jason, Beth's, and Luke's contact information. You can feel free to reach out to them with any questions that you might have after the session is complete. Thank you again for joining us, and I hope we'll see you on December 14th for our talk on climate change. Have a good day, everybody.